So let's have example. This example. We have a compound beam, and the reason why it's compound because we use a link to connect two beams to form a much longer beam. That's why it's compound beam, because of this link. So whenever not a link or cable, then we know already that a link or a cable in this reaction, it's gonna give us a tensile force, but it's an internal tensile force because this is an internal link, so it's not used as an external link. So when man na ay external link, so na external link when the link itself is connected to a different structure, like it's connecting the beam to a different structure like wall or such column. So since the link is used to connect another beam, then the link is considered as an internal. Anyway, so I'm being technical in terms of usage of this link, but actually it's just a connector. Okay, so you will be able to encounter more other links whenever you continue with the structural analysis for the civil engineering. Anyway, let's proceed with the assigning letters from the left to the right in every change of loading. So I hope you're already familiar how to write letters. So this is point A, this is point B, and of course this is point C. Somehow this is also another point C because they are sharing the same point. And then this is point D, and this is point E. Alright, so next is you draw the free body diagram. So in my case, I have already drawn the free body diagram. And then what I'm gonna do is, of course, transfer the letters A, B, then C, and then this is D, and this is point E. And of course, if there are forces on their inclined and distribution, then we have to get its components. Like for 50, this one is downward, and this is 50 sine of 45. And then this one here is to the right. This is 50 cosine of 45. Also, we have a trapezoidal loading. What we're gonna do is separate the trapezoid into rectangle and triangle. So I'm going to separate the figure. So I'll just draw a horizontal line, and I'll just make it in broken line just to denote that we're actually separating the figure. So this one is for the rectangle. So I'll just rearrange that. And then this is for the triangle. So it's not making a triangle. So let's draw another. Okay. So this is for the triangle. Okay, so there will be two resultants. One is for the rectangle. It will give us this one, 10 times 3. So that's 10 times 3, that's 30. Then the other one is a triangle. So this is for the triangle. So the remaining length here of the distribution, it's no longer 20 but rather 20 minus 10. So this is 10. So therefore, it's now the product of 1/2 times this 10, kana siya nga 10, and then times 3. And this is 15. I hope you're wala mo naglibog ana. So I'll just remove this because it's kind of clutter. Okay, and since this is a compound beam, then we're gonna proceed in writing the letter, writing the reactions. So at A, there is a hinge, so it's gonna be A vertical and A horizontal. So I'm gonna make A horizontal to the left. The reason, because we have this 45 to the right. 50 cosine 45 to the right. So I am anticipating that it's going to be counteracted by AH. And then also here I'll have at point D there is a roller, so I'll have here a roller, so this is D vertical. And then at point E there is another hinge, so it's going to be E vertical and E horizontal in a way. So this is just my assumption. Okay, what we're gonna do now is we're going to separate the beam. So remember that we did not place any reaction here, although it is a link, but it is an internal, meaning when internal support is used, we are not going to place any reaction when the entire beam is intact. But when we separate the beam, like this one, I'm gonna separate it now. Like this, I'm gonna separate the beam. I'll separate the beam, so I'm just going to erase this and this one. And then the other, so I'll separate it also. I just wanted you to get the difference of the two. So I'm separating it. So I'll just remove this one, this. And as you observe, akong gipabilin ang iyahang support. So what's happening? Okay. So naa kay nakitaan nga mga links. So basically, we will be replacing them as reactions. Since this is a link, then it's gonna be a port. It's going to be a tensile. So that's going to be CV. So pag separate, dito na nakita ang iyahang internal nga reaction. Kay gi-separate man nato, meaning we break the link. And then also for this free body diagram, the link now is downward. Why it's downward? Because it conforms to the concept that a link will produce a tensile force. So it's pointing away from point C. And thus, this force CV upward and this force CV downward makes equilibrium. That the moment imo siyang i-combine, that CV upward and CV downward is just equal to 0. So ma-cancel out sila. So 0 equal to 0, pasabot wala siya'y reaction, meaning balance na siya. So that's what we're gonna do whenever naatay mga internal supports. So I'll just remove that. Okay, so in this instance, we now proceed in solving the support. So this is our free body diagram number 1, and this is our second free body diagram, or free body diagram number 2. Okay, so we are now going to consider the beam separately. So in my case, I will be counting the number of reactions that are unknown. So in this case, we have 1, 2, and 3. So there are 3 reactions. So there are 3 reactions here. And then from the previous or the other free body diagram, the number of reactions is 1, 2, 3, and 4. So there are 4 reactions. Meaning to say, we're going to compare the two free body diagrams. The one has 3 reactions, then the other has 4 reactions. Remember that we have only the summation of forces vertical, summation of forces horizontal, and summation of moment. So in this case, we're only allowed to use which mo conform siya sa algebra. If we have 3 equations, like this equation 1, equation 2, and equation 3, somehow it's giving us an idea that it can only solve 3 unknowns because we have equation 1, equation 2, and equation 3. So comparing the two, this is 3 and this is 4, then immediately this this equation can solve immediately this one, but not this one here. So in that case, we will be considering the first free body diagram. So I'll just remove this one. Again, we will be using or considering the free body diagram number 1, this one. We will be considering this free body diagram here because it has only 3 reactions. Unlike here, there are 4 reactions, so we cannot solve anything yet. So starting with this free body diagram, let's move this a little bit lower because we will be solving this free body diagram. Then let's have summation of forces horizontal equal to 0, to the right positive and to the left negative. So what are the forces horizontal? You have AH to the left, so that's negative AH, and then this one, cosine 50 cosine is to the right, so that's positive 50 cosine of 45, and that's equal to 0. Okay, so with this we'd be able to get our AH. So transfer AH to the other side, it will give us 50 cosine of 45. So AH now is equal to, so that's gonna be 50 cosine of 45. That's 35.36 kilonewtons. This is our reactions. So later on, we're gonna check whether our answers are correct or not, okay? And then next is, let's move it a little bit to the left. Okay, next is we're gonna do the summation of moment about either point A or point C because these are the only 2 points that has reactions. So I'm gonna rotate about point C, and it's clockwise positive, counterclockwise negative, and that's going to be A vertical, and that's upward, so it's gonna rotate clockwise about point C. So it's upward and it's gonna rotate point C with that direction, so clockwise, and that the moment arm is 4 meters. So that's the distance from A to C is 4 meters. And then this one, it's downward, so it's negative 50. Doesn't mean a downward negative 50 siya. So actually it's downward and it's gonna rotate this way. So it's counterclockwise because it's downward and it's rotating about point C. So it's negative 50 sine 45 times the distance is 2, and then that's equal to 0. So transposing the constant to the other side, it will give us 50 sine of 45 times 2 divided by 4. So we are solving now A vertical. You get your calculator, and this is 50 sine of 45 times 2 divided by 4. So the answer is 17.68 kilonewtons. So this is our answer. Okay, next is we're gonna have the summation of forces vertical equal to 0. So you have upward positive and downward negative. So what are the forces on the vertical side? So actually it's AV, so it's AV upward plus CV upward minus 50 sine of 45, and that's equal to 0. So substitutes AV 17.68 plus CV minus 50 sine of 45 equal to 0. So CV now is, so let's get this calculator. So CV, it's actually transposing all the constant to the other side. It will give us 50 sine of 45 minus 17.68. So our CV now is 50 sine of 45 minus 17.68. It's 17.68 kilonewtons. And from here, we can actually now do the checking. So it's really up to you if you'd like to do the checking here. So kung ganan lang ka makibaw that before you proceed to the next free body diagram, ganan lang ka makibaw that your answers are correct, then you may do the checking, summation of moment at the other support. Since we're done with summation of moment at point C, then the next summation is at point A. So it's going to be negative CV times 4. It's negative because the force is upward and it's gonna rotate about point A with a counterclockwise. And then plus 50 sine of 45 times 2. Why it is plus? Because this force is downward, so it's gonna rotate about point A. So that's plus clockwise, and then that's equal to 0. But CV is 17.68, so you're gonna substitute negative 17.68 times 4, then plus 50 sine of 45 times 2 equal to 0. So we're gonna investigate if that is 0 equal to 0. So that's 17.68 times 4, then plus 50 sine of 45 times 2. So the answer is negative 0.009, and then that's equal to 0. Anyway, this one is just approximately 0. So 0.009 is approximately 0, and that's equal to 0. Okay, so we have proven that our answer here for this free body diagram is correct. So just in case you wanted to know whether your answer is correct or not. Okay, let us proceed to the next free body diagram since we're done with this first free body diagram. So remember this one, this free body diagram. Let's copy this. It has 4 reaction, so let's just move this one. Anyway, we practically moved the other beam, so this is our second free body diagram. And remember that our CV from the previous free body diagram, we had CV as 17.68 because we need that CV. So this is now equal to 17.68. So as you can see, we only now have 3 unknowns because ganina gi-count man nato as unknown, but this time it's no longer unknown. Kana siya dili na siya unknown, kaya na siya value 17.68. So therefore, there are only 3 reactions na lang. This DV, EV, and EH. So kani di ay, it has 4 reactions now. I mean 3 rather. Okay. So in this case, we are now ready to solve the reactions, excuse me. So I'll just transfer it here. And then let's measure first the distances. So this distance padung sa EV, this is 1/2 of 3. So this is 1.5. Also, about point D, this is 1.5 as well. 1/2 of 3. So 1.5. And then also, I'll just move this here a little bit downward or down, and then let's measure the distance of this resultant from here, point D. This is basically 1/3 of 1/3 of the length of the distribution, so that's equal to 1. And padung sa right side, so here padung sa right side, this is actually 2/3 of 3, so this is 2 meters. So now we have that distance already, so we are now ready to do the summation of moment or force horizontal. So let's do the summation of force horizontal, and that's equal to 0. That's to the right positive, to the left negative. So here we only have EH, so therefore EH is equal to 0. And then let's do the this is your action, by the way. And then let's do the summation of moment about point. I'd like to have the summation of moment. We only have choices D and E. Do not choose C because you're not gonna solve anything. So you have to choose D and E only. So I'd like to use summation of moment about point D. So rotate about point D, clockwise positive, counterclockwise negative. So it's gonna rotate CV with a rotation about point D, it's counterclockwise. So it's negative CV times the distance is 2 meters, and proceed with this 15 resultant is downward, so it's gonna rotate clockwise. So it's plus 15 times the moment arm is that distance, 1 meter, because this distance is 1 meter. Okay, so that's 1 meter. Next is this 30. So the 30 is downward, so it's gonna rotate about point D with a clockwise. So that's plus 30 times 1.5, because the moment arm is found 1/2 of 3. And EV is upward, so it's gonna rotate counterclockwise about point D. So it's counter. So it's negative EV times 3 meters. The distance of point A from point D is 3. And let us substitute CV, which is since it's negative, so you substitute 17.68 negative, and then times 2, then plus 15 times 1, then plus 30 times 1.5. Then you transpose EV to the other side, it will become positive EV times 3. And solving for EV, it's going to become negative 17.68 times 2 plus 15 times 1 plus 30 times 1.5 and divided by 3. So we now have EV. So for EV, you substitute, you compute negative 17.68 times 2, then plus 15 times 1, then plus 30 times 1.5 divided by 3. So the EV is 8.213, or that's 21 kilonewtons. Okay, so now we have this EV. What we're gonna proceed is do the summation of force vertical. So let's just move it here. So let's do the summation of force vertical equal to 0. So what are the forces vertical? You have negative CV. By the way, it's upward positive and downward negative. So it's negative CV. Let's move this a little bit to the right. Yes. Okay, that's negative CV, then plus dV, then plus EV, because these are the forces upward, then minus 15 because it's downward, and minus 30 because it's also downward, equal to 0. And you substitute the values of CV. So this is negative 17.68 plus dV, then plus EV, which is 8.21, and then minus 15, then minus 30, then that's equal to 0. So we have dv now. Transpose it to the other side, or the constants to the other side. It will give us dv equal to 17.68 minus 8.21 plus 15 plus 30. So our dv is now solved. So let's get our calculator. That's 17.68 minus 8.21 plus 15 plus 30. So you have 54.17 kilonewtons. And this is our final answer for dv. So let's check whether our answer is correct or not. Since we did the checking from the previous free body diagram, let's also do the checking here. So I'm just gonna transfer this, or copy. I'll just copy this one because I'll do the checking. This one here. So let's do the checking. I'd like to do the checking here. So let's check. Since we're done doing the summation of moment at point D, then let's try to have the summation moment at point E equal to 0. So it's clockwise positive, it's counterclockwise negative. So it's point D. So it's CV, it's downward. It's gonna rotate about point A point E rather, with counterclockwise. So it's negative 17.68 times the moment arm is 5, because the distance of point C from point E is 5 meters. And then dV, it's upward. So upward influence is clockwise rotation. So it's plus dV times the distance is 3 meters. And then 15, it's downward, and it's gonna rotate about point E with a counter. So that's negative 15 times the moment arm is 2 meters. Okay, I have already solved that also. Then for 30, so it's downward, and it's gonna rotate counter about point E. It's negative 30 times 1.5. What else? No more. Equal to 0. So this is you substitute dv, by the way. dv is, how much is dv? 54.17. Okay, let's get our calculator. So that's negative 17.68 times 5 plus 54.17 times 3, then minus 15 times 2 minus 30 times 1.5. So it's negative. So it's negative 0.89 equal to 0. It's quite a lot. What happened? So let's check whether we got this correctly. 17.68. Okay, this one, let's check whether we got it right here. So it's negative 17. Let's just check whether we got it right. So this one, let's investigate that. Negative 17.68 times 2 plus 15 times 1 plus 30 times 1.5 divided by 3. So it's 8.21. Okay, so we have 8.21. So it's upward. And you have this one. Let's investigate this. That's 17.68 minus 8.21 plus 15 plus 30. Oh, it's 54.47. This one. So diririta na sa'yo. 54.47. Okay, so this one, dv, this is 54.47. Okay, so let's check once more. So that's the important of having the checking. Para you would know you you got mistake or you got the answer correctly or not. So let's do the checking now. 17.68 68 times 5 plus 54.47 times 3, then minus 15 times 2, then minus 30 times 1.5. So the answer is 0.01. So our answer here is 0.01, and that's equal to 0. So somehow 0.01 is approximately 0, and then that's equal to 0. So this is correct. Okay, so this is our example.